Atomic Motions Project by Zanira Watt. Solids. Key facts that can be determined about solids are simply that solids can be hard like a rock, soft like fur, and a big rock like on the beach, or small rocks like grains of sand. The key is that solids hold their shape and they don't flow like a liquid. A rock will always look like a solid unless something happens to it. The same goes for a diamond. Solids can hold their shape because their molecules are tightly packed together. The crystalline is a solid is higher than when it is in a liquid because when the solids sink with its density being higher also. The phase transitions from a liquid to a solid is freezing. Amorphous ices are metastable forms of ice. They are kinetically stable in the pressure temperature. They can therefore exist for short periods of times or long periods of times. Solidity is when chemicals in a solid are tightly packed together. Liquid. Liquids fill the shape of any container they are in. If you pour a liquid in the cup, it will fill up the bottom of the cup and then fill the rest. If you freeze that cup of water, the ice will be in the shape of a cup. The top of a liquid will usually have a flat surface. That flat surface is a result of gravity pulling on the liquid molecules. Liquids are loosely packed and flow very easily. The phase transition for a gas to a liquid is condensation. Liquids are not tightly packed, but they would rather stick together because of the forces that pull the molecules together. When viscosity is in the image, it prevents the liquid from flowing. Buoyancy is when the liquid is forced to rise up or forward. Fluidity is when the liquid is able to flow easily. The current in a liquid make up of positive ions and have negative ions flowing in the opposite direction. Floatability enhances the separation of molecules that take place during the reaction. The density of liquid is the mass and size of the molecules, and how closely packed together determine the density of any liquid. Gases. The atmosphere is an envelope of gases surrounding the Earth. The molecules in gases are really spread out, full of energy, and constantly moving in random ways. Gases can fill a container of any size or shape. It doesn't matter how big the container is. Gases hold huge amounts of energy, and the molecules are spread out as possible. The difference between vapor and gas is a state of matter while vapor is not. Also, vapor has to undergo phase changes while gases do not. Idle gas contains no volume while real gas contains little volume. Real gas has small forces while idle gas has none. The rapidly moving of particles can constantly collide with each other in the walls of the containers. Diffusion is known to move fast in a solid because they have higher temperatures. Effusion goes through this little hole which is equal to the mass of its particles. Gas laws make up three laws that say altogether the gases respect the laws with how they behave with respect to pressure, volume, temperature, and amount. The energy to compress a gas or the energy obtained from expansions can be estimated by calculating the idle work and applying the right value. As you know, gases blow up and explode in volcanoes. Plasma. Plasma are like gases, but the atoms are different because they are made up free electrons and ions of elements. They are direct and unique from the other states of matter. Plasma is direct from a gas because it is made up of groups positively and negatively charged. In neon gas, the electrons are all bound to the nucleus. In real life examples of plasma would be stars in the sky or a neon light. Plasma is ionized gas in which energy is provided to free electrons from atoms and molecules. When the electrons get close to the nucleus, this is when the plasma is called penetrability. Any surface that is emerged with plasma, including fusion reactors, is surrounded by a layer of electrical charge. Plasma preparation is when the scientists test blood or do blood testing. Real life examples. Real life of solids include copper, brass, bricks, sand, butter, and aluminum foil. Real life examples of liquid include blood, urine, mercury, bromine, honey, and coffee. Real life examples of gases include nitrogen, hydrogen, helium, and carbon dioxide. Real life examples of plasma include lightning, solar wind, aurora, or nuclear fireballs. And here are pictures.